Hello friends! Our objective for the first section of this course is to create a 3D character that the player can control in third-person perspective. Our first lesson will be setting up a basic 3D scene in a new project. Opening Godot for the first time, there are no projects. So Godot recommends exploring official sample projects. Press cancel to ignore this recommendation. We will be starting a new project from scratch. Click on the new button to create a new project. We will need to give the new project a name. I'll name mine Godot 3D course. And select a folder on your hard drive to store it. I recommend making a folder for Godot projects in Documents. Then click the Create Folder button to create a new folder at this location with the name of the project. You can change the renderer settings for your project. Forward is best for high-fidelity PC or console games, or the mobile renderer for mobile devices. I like to use the compatibility renderer for most projects because it is most compatible with web builds that can be uploaded to sites like itch.io. Lastly, Godot supports integration with GitHub version control by default. Click on Create and Edit to create the project and open it for editing. The Godot editor window is divided into several tab docks. In the center is a preview of what the current scene looks like, as well as several tools we can use to edit things. To the upper left is the Scene tab, which holds a list of everything in the current scene. Below that is the File System tab, which holds all of the imported assets for our project, like models, textures, sounds, and music, as well as all of the files we will create using the Godot editor, like scenes, scripts, and resources. Currently, the only file here is the Godot logo. To the right is the Inspector tab, where if we select anything in the scene, we can see its properties and edit them. All of these tabs can be resized and rearranged as you see fit to best accommodate your workflow. Our scene is a vast empty 3D space divided by three colored axes. The red x-axis represents right and left, the green y-axis represents up and down, the blue z-axis represents forward and backward. Let's get started by clicking on the 3D Scene button in the Scene tab. This has created a root node for our scene in the Scene tab named Node 3D, which is also the node's type. We can rename this node by double-clicking on it, or right-clicking and selecting Rename. In many games, this scene will be referred to as the main scene or the game scene. You can also name it after the style of gameplay that will be used, such as the platforming, exploration, combat, or puzzle scene. I'll name mine Game. This root node will form our scene tree as we add branches to it. Either click on the plus button or right-click on the root node and select Add Child Node to add a branch to the scene tree. There are many different node types to choose from that serve many different purposes. Node types follow a hierarchy of inheritance, so all nodes share the common type node, but then there are Node 3D, Canvas Item, Node 2D, Control, each with many different subtypes. If you know what you're looking for, you can type the name of the node into the search field. Let's add a Mesh Instance 3D node. You can see that a Mesh Instance 3D node is inheriting properties of a Geometry Instance 3D node, Visual Instance 3D node, Node 3D, and Node. Click the Create button to add the Mesh Instance 3D node to the scene tree. You can see that the node is added to the scene tree, but it is indented, to imply that it is a child of the root node. Any node with children can be collapsed or expanded to hide or show its child nodes. This is supposed to be a 3D image, but nothing is displayed in the preview window. That is because this mesh instance doesn't have a mesh resource telling it what to draw. With the Mesh Instance 3D node selected, look in the Inspector tab to view and edit the node's properties. The properties are divided into the same types we saw when creating the node, so we can see which properties are inherited from different types and which are specific to our mesh instance. We can see that the mesh field is empty. Clicking on the dropdown, there are several options, including some basic shapes: box, capsule, cylinder, quad, prism, sphere, and torus. Let's make this shape a plane. Now we can see a 3D shape drawn in our preview. Clicking on the mesh resource expands its properties so we can view and edit them as well. Here we can set the size of the plane in both the X and Y dimensions by either typing a number into the field or clicking and dragging on the field label. Units are generally considered to be meters, or approximately 3 feet in imperial measurements. But there is no requirement to use this ratio. In a strategy game, a unit might be a kilometer or mile, or if you're playing as a tiny insect, then a unit could be a centimeter or an inch. Now that we have something in our scene to give us a point of reference, let's explore the scene a little more. There is a grid of lighter gray lines dividing the XZ plane into units, with every 8th line being lighter. We can zoom in or out using the mouse wheel. Zooming out, we can see that this pattern continues as each 8th larger subdivision is also marked, 64 units apart, which is 8 squared. And again every 8 or 512th unit, 8 to the power of 3. Zooming back in, the original grid becomes visible again. Holding down the mouse wheel and moving the mouse allows us to rotate the world about the y-axis, and also tilt our perspective up or down. Holding down the right mouse button and moving the mouse allows us to rotate our perspective, looking right, left, up, or down. Still holding down the right mouse button, we can use the WASD keys to fly through our scene while also using the mouse to orient our point of view. If it seems like you're moving slowly or not at all, you're probably zoomed out. This allows us to quickly and easily view our scenes from any position or angle. The mesh only defines the shape of a 3D object, not its color, lighting, or anything else. Those are all set by a material. Expanding the drop-down labeled material, select New Standard Material 3D. Then click on the newly created material resource to view and edit its properties. Materials have a lot of properties to control how they interact with light. Expand the albedo section. Here we can adjust the color, or also use a 2D image file to apply texture to the material. Try dragging the Godot logo into the texture field. If there is both a texture and a color, then each pixel's color will be multiplied by the color value to produce the result. In the upper right corner is a series of buttons, one of which is a clapperboard with a play icon. Run current scene. Clicking on this button will prompt us to save the current scene if we haven't done so yet, otherwise it will save the scene automatically. This allows us to run a simulation of our game starting from this current scene that we are editing. Nothing is displayed. We can close the window to end the simulation. This is because there is no camera in the scene. A camera is required to view 3D scenes. A camera is just another node type, so we can add it to the scene the same way we added the mesh instance. We need to use a camera 3D to view 3D scenes. The camera is added at the scene origin, which is the center of the floor, and is looking in the negative Z direction. We can see which direction a camera is looking as well as the width of its field of view based on the magenta gizmo, shaped like a pyramid. And the triangle shows us which direction is up as well. With the camera 3D node selected in the scene tree, clicking on the preview toggle will show us what the camera sees. Where the camera is sitting right now, it can't see anything. Click the preview toggle again to return. We need to move it away from the floor and rotate it to look at the floor. We can move the camera easily along a single axis by clicking and dragging on any of the 3 arrows. Red for the x-axis, green for y, and blue for z. We can also move the camera along a plane by clicking and dragging any of the 3 squares. This will lock the associated x, y, or z value while we move the position along the other 2 axes. Move the camera up along the green axis and forward along the z axis. Depending on the perspective of your editor, forward may seem like backwards. But for clarity, forward is used to refer to the positive z direction, which is the direction the blue arrow points. This can also be done by locking the red axis and moving the camera along the YZ plane like so. Next, we need to rotate the camera to look down at the floor. We can rotate about a single axis by clicking and dragging any of the 3 circles. Rotating about the green y-axis will be like turning your head to the left or right. Rotating about the blue z-axis will be like tilting your head to either side or even upside down. Looking down is a rotation about the x-axis, which is red. Click the preview to see if your camera can see the floor clearly. With the camera 3D node selected, look in the inspector, in the properties inherited from node 3D. Expanding transform, we can see that the position and rotation values of the camera have been edited. All 3D nodes will inherit this property for controlling their position and rotation in 3D space. Here we can manually edit the values, or we can click and drag on the labels to adjust them with the mouse like we did with the plane. Scale is a multiplier of a 3D object's size. By default, the x, y, and z values are all linked together, so editing one will edit all 3. Cameras don't have size, so changing the value doesn't affect the camera, but setting the scale to a negative value will effectively mirror its rotation. We can reset the scale to 1 by clicking on the reset button and ignore this property. Checking the preview, the camera can now see the floor, but if we run the current scene, the floor is black. This is because there is no light source in our scene. In the editor, the floor is illuminated because there is preview sunlight and environment, which we can toggle on or off using these buttons. Turning them off, the floor turns black, which is what we see when we run the scene. So for the camera to be able to see the floor, we need to add a light source to the scene as well. Add a directional light 3D node to the scene. Like the camera, it is added at the scene origin, facing the negative Z direction. A directional light simulates sunlight, producing parallel rays of light over the entire scene. Its position does not affect its behavior, only its rotation. We can move and position it anywhere in the scene, preferably somewhere where we can see the white arrow gizmo. This arrow points in the direction of the light rays. Rotate the light source so the light is pointing down towards the ground, illuminating it for the camera. Now if we run the scene, the camera can see the floor thanks to the light reflecting off of it. Every runnable game needs to have these 3 basic components: something to look at, a camera to see it with, and a light source. If you need to practice with 3D positions and rotations, try making an abstract 3-dimensional art piece using mesh instances. Note that lights do not cast shadows by default. To enable shadows, click on the light source node, expand the shadows section under Light 3D, and click on the enable toggle. You can also add additional lights to the scene, adjust their energy or color to produce a wide variety of lighting. Feel free to experiment with different properties of materials and how they interact with lighting as well. When you're done, you should have a good understanding of the relationship between meshes, materials, cameras, and light sources, how they're used to create a 3D scene, how to move and rotate objects in 3-dimensional space, and how to navigate your scene. In the next lesson, we'll start receiving input from the player. I'll see you in the next lesson.